Hello everyone, it's March the 8th. So look at this 3005. That was a new problem for sure. What's this? Turn you off. Okay, so what's this? Count elements with maximum frequency. You're given an array, positive integer, total frequency of elements in num such that those elements all have the maximum frequency. The frequency of an element is number of occurrences. Return the total frequencies of elements in num such that those elements all have maximum frequency. So in the first example, we have 2 and 1 both have frequency 2, so the sum is 2. In the next one, all of them. Okay, so we have to go through the whole thing, count the frequency of each one, right? And then we basically go to ones, record the frequencies, because the number is at the most 100, so we can probably just get away from just get an array of size 100. So we go through this and then we fill it out and we go through again. Go through again. So you have two choices. You either go through again and you need to find. Now I can do one pass, right? I can do one pass and just keep track of the sum, right? We just keep track of the sum. Yeah, okay. That shall be okay, and that's not too bad. All right, let's do this. Okay. All right, actually, let me undo this. Because actually no, not undo this. I shall undo this, right? And I then redo this. There we go. Now we're good. Okay, so I need to say int counter equals int 101, right? And then we basically for int n of nums, we say counter n plus, right? And then int max equals 0. What is 0? Yeah, max is 0, int res is 0. For int I equal to 1, I smaller equal to 100. All right, 100 I plus, and then we say if counter I is equal to max, then rest plus equal to max, right? Else we probably need to have this, unfortunately, so we're gonna do this, right? Else if counter I is larger than max, in which case we're gonna say res equal to max. No, we say max is equal to counter I and res is equal to max. And then at the end we're gonna return res. Okay, I think I have some syntax error up there in the 13. That should be new. Okay, so okay, let's. What did you do? No, I didn't do anything. Okay, let's put it here. Get through this, run it. Of course, we'll create some test case. Wait, what? Oh, I think I pressed some button here. Oh my goodness, I know what I did. There you go. I must press a button to change all the uppercase and the lowercase stuff. Absolutely bonkers. Okay, So I'm gonna run this. Yeah, this one, nothing really to say. Pretty easy. This is what? Oh shoot! Come on, man. This is 3005. I think there's gonna be another solution. Count frequency and max frequency, yeah? Sort frequencies and sum max frequencies. What are you saying? As we go through, we update, and then if it's bigger, then I just do it. If it's the same, I do it. If it's bigger, oh, maybe. Yeah, maybe we can do it in one pass. Seriously, I think we might be able to do one pass. And of course, because they already said you can do one pass. So, okay, let's try. Let's try one pass. So we have to have counter, but we don't need this, right? We just go through this for int n of nums, right? And now we say counter I, not counter I, n plus plus, right? And then if this, and then I think everything else is the same, right? If it's equal to max, then we do this. If it's larger than, I reset. And the next one, if it gets larger, I reset. And larger, we get reset. Yeah, this will actually work. Holy crap. This might actually work. This will actually work. Yeah, one pass works. All right, good. All right, let's try this. So we had the idea yesterday of doing this, which is basically, yeah, let's recap our idea from yesterday. Okay, so the idea yesterday is we'll sort it. Okay, we say we'll sort items based on profit, okay, and then ascend. That's how I sort. And after sorting, we take the last k items, right, and we'll compute the elegance. Okay, we come to the elegance of the last k items. Then, and also we have find the unique, right, categories of the last, right, k items. Then what we're gonna do is go through, right, we'll go through the remaining, right, elements, and only, oh, we don't have to choose. That's actually, no, this is actually, that's not necessary. And then what we're gonna do is we need to right, go through the k, go through the k elements. Right, we go through the k elements, and we need to find out if there is any duplicates. All right, and see if there are repeated categories. Right, any repeats can try to be replaced, right, with a unique category that's currently not included, right? A new category not included with the max profit, right? And then we just keep replacing, right, the low profit one until there is no more replacement. So this is how I think, right? Until there's no more replacement. Because if you replace the unique ones on the right hand side with something, and then you get a lower score, you get a lower profit. That's why I think it's not really good strategy. Okay, so this is what 1, 3. Okay, let's try this. Okay, we will not do Java on this. All right, so first things first, we're going to sort items based on the profit. The first one's profit, right? Profit category, so perfect. I can just call it items.sort. Right, we sort it, right, and then we will say the initial. We can say res equal to. We also need to know the frequencies, right? We need to know the frequency. Okay, we need to know frequency. We need a counter. Right? So we need to know frequency equal to counter, and then we say for I range. Okay, we also need an n. Here's len items, right? Range what? I guess it's n minus k, but I need to think about it. So last k, right? So if I have 5 and I say k equal to 3, so 5 minus 3 is 2. 0, 1, 2, 2, 3, 4. Yeah, that's actually correct. So we go this, and then we also need we call it res. What we want is the maximum, right? We want a maximum elegance, so we set it to 0, which is yeah, it's okay. So we set it to 0, and we just go through everything. Then we say first of all, res will plus equal to items I 0. That's the profit, and then frequency items I 1 will plus. There's no plus, right? So we do that. After we're done, we say res plus equal to len frequency squared, right? So that's, we say the unique category is doubled. And then what we're gonna do is we're gonna go through the whole thing, right? We have 2 pointers basically now. Now we have 2 pointers, so we have I, j shall equal to, I is gonna be n minus k, j is n minus k minus 1, right? And I say while I is smaller than n and j is larger equal to 0, okay? What we're gonna do is we will go through I to check if it has any duplicates, right? Then we just say if the frequency of items I categories 1 is larger than 1, okay, if it's larger than 1, then we can try to replace. Now how to replace? We need to check the j, right? We check the j, and then for j I need to go a while loop. We say while j larger equal to 0 and items j, right, and 1 is not in frequency, is in frequency j1 minus equals 1. Okay, so this is actually we need to say in frequency, j minus equal 1. Once we get out, we say if j is larger equal to 0, because it could be go through. If j larger equal to 0, then we can try to do the swap, right? How do we do the swap? We basically say the res shall equal to maximum. The res will basically add or minus, because I remove items I 0, I will plus items j, right, and the 0, and plus 2 times n plus 1. I think that's basically what we're trying to say, because we're increasing, right? We're increasing the number of unique values. So previously, this, I'd say I will have m, now is m plus 1. So what we're gonna do is we're gonna do m plus 1 squared minus m squared, which is 2m plus 1, right? So that's what we are putting here. We plus 2 times, ooh, n. What the hell is n? There's no such thing as n, right? There's no such a thing as n. So we shall actually define it as n is equal to ln frequency. Okay, so this is, I'm gonna say this is the original number of unique categories, right? And then as we do this, each time we add one unique, and every time we add one, we get this amount added. So now we get a maximum of the rest. That is actually not correct, because I need to have a sum, right? So I should have, what's it called? It's elegance, okay, elegance, and the rest is equal to elegance to start with. So here, elegance, actually, let me change this. So we actually have to do is elegance is equal to this. Of course, it's not, and that's not rest here. It's elegance. We do this, and then this is gonna be elegance. Right, rest gonna always keep the biggest. Right, now we do this, right? We replace it, and then we go back up. Right, we go back up because we replace it. Yeah, we basically replace this, and after we replace it, j needs to minus equal 1. Right, j needs to minus equal 1. And then once this whole thing is done, on the outside, I shall plus equal 1. So I always move forward, right? So we just check if frequency is larger than 1. Then we do it. Oh, and we need to update the frequency as well. So we can say frequency items I1, this one minus equal 1, right? Minus equal 1. Because we basically replace it. So the frequency needs to decrease, right? And then when it gets out, I move forward, right? But we don't really have to change any value in the items, because we kept the record. And then the next one we check. If it's still larger than 1, then we can do another replacement, right? We'll do another replacement until we hit it's 1. Then we don't do it, then we just keep moving, right? We keep moving. And once it's done, everybody's out, then we return rest. Need type annotation for frequency. Cannot determine type of elegance. Of course you cannot, because this is not supposed to be, this should be elegance, right? This should be also elegance. This should be elegance and elegance. And here, can I do counter? I don't know. What's the, is that B? No. It's a P? No. Damn it. A D? F. F and D. Yeah, F and D. Forward and then backward. It didn't really say how to type hint this. Can we do this? Oh my goodness, you can. Yeah, you can. You can. Okay, now let's give this a shot. This is definitely, it's greedy solution, right? It's very much greedy. We'll try to see if it works. Okay, it works for these, and just don't type too much. Just this is an attempt using greedy. All right, let's see if it works. Nope, does not work. Okay, so greedy does not work. And if greedy does not work, that's gonna be a long day. Okay, that is gonna be a long day. All right, so we have 2, 2, 2, 4, 4, 5, 8, 6, 9, 5, and 10, 6. So greedy doesn't work. So what I do is 4. So I say I group these together. So that's 4 times 8 times plus 9 plus 10. What was that? That's just 12, 21. This is 31, and 5, 6, 5, 6. So plus 4. So that's 35, right? And I say I'm gonna replace. I'll replace this. Right, so I replace this, I include this as 4. So basically, that's going to be 35 minus 4 plus 2. And plus, oh, I think I know. I should update the n. This n needs to be updated. My bad. So that's the initial one. Now once we're done, n needs to be updated as well. Okay. N needs to be updated as well. Yep. All right. Let's try it again. Okay. So yeah, let's just debug this. I mean, this is a little bit. Let's debug here. Anyway, so we have n need to plus equal 1, right? That's the only change we made. Frequency, and then we do this. That's all right. That's good. No, we're gonna do this. Okay, so we do this. Answer supposed to be 51. Okay. So we have items k, and this is supposed to be find a maximum, and this is items and k. What is s doing here? Okay, so we put 21. So we put a breakpoint here. Save it. F5 1. F5 1. Okay. Yeah, move this one here. Okay. So where are we? We are here, and we have items sorted based on this. Frequency we have 1 is 3, with 5, right? So 1, 2, 3, 4, 5. Frequency 1 is 3, 5 is 1, and 2 is 1. Okay. And J, so 0, 1, 2, J is at 2, I is at 3, perfect. N is 3, perfect. Rest current is 48. Okay. So we're at this 5. Frequency is larger than 1. Oh. What? Oh, 5. Frequency doesn't. So we don't do it. Okay, I plus equal 1. So now I is 4, is 6, 2. And 2 is only 1. Okay, go up. Then we have 8. Ooh. So wait, hold on. So we have 8, right? 8 is good. So while J is still has 2, and it's in frequency. No, it's not in frequency. We get out. J is larger than 0. Okay. Elegance is 48. So we're gonna minus this, so minus 8, plus 4, so minus 4, so it's 44. 44 plus 2 times, because current is 3, 2 times 3 is 6 plus 1, 7, so 51. Yeah, elegance becomes 51, the rest become 51, and then J minus equal to 1. Oh, I see. I see, because when you add it, oh, okay. All right. Because it's a 4, you add another 4, so you couldn't, right? You shouldn't. Now, the question is, do we include the duplicates on this? Well, I mean, if we include, right, then that one will lose. Well, we'll lose because we're replacing something with something smaller, so we'll lose. So it will always be smaller, right? Because we cannot increase, so we shouldn't, right? We shouldn't. Okay. So here is my take on this, which is J logical to 0, right? And also we have to do the frequency. So frequency this and the frequency items J and 1 plus equals 0, plus equal 1, right? And then it has to be, this is larger than 0, and frequency items J 1 has to be equal to 0. It cannot have, and then we add 1, right? So we do that, and we save this. We can actually run it. F5, do 1, we run it. Can we do this run at the end? Did you get a result? Pass, right? It passed. I saw it pass. So 13K. Okay, that was an oversight. I did not pay attention to this. We shall put it. All right. Try using greedy. Try this. Ooh, that was very interesting. 38, 39. One of them is wrong. Damn. Did you forget something? Interesting. This is wrong. Damn it, I can't even select it. Okay. Let's go back here. That's all right. No, we just debug. So the answer shall be 39. I only get 38. 39. Okay, let's debug. All right, everything right. 22, 24, 45, and then k is equal to 4. So we cover these 4. 5 is this. 6 is this. Okay. Now we're gonna go. Oh, that's perfect. The first one is larger than 1, so we're gonna swap. And so it's 2, 4, right? Is in frequency? No, so we can get J, and this is good. So elegance is gonna be, current elegance is 35 minus 4, okay, minus 4 and plus 2, so minus 2. So 35 minus 2, 33, and then plus the current n is equal to 2. So 2 times 2 is 4, plus 1, 5. So that's 38, right? So elegance is 38, rest becomes 38. J minus equal 1. That is good. J minus equal 1. And the frequency, the 5 become 1. Right? 5 become 1. And frequency 4 increase. Huh? What is 2? Oh, shoot. Shoot. I know why. You should not. You should not do it here. You should do it here. My bad. My bad. That was silly error. A silly mistake. Okay, it's a very silly mistake. All right. Anyway, so this is an attempt of using greedy. That was not really that difficult to discover. It was I do this too early. All right, let's try it again. Let's hope this one is right. This one is correct. So greedy is correct. That was not too bad. That was not bad at all. Codicioso funciona. Funciona muy bien en este problema. On, right? It's greedy. Right, so we say sort items and pick the last k as the initial elegance, right? Then we go through each of the last k from the smallest profit to the largest, right? Largest. If any element, if any item belongs to a category that has more than one element, one item, it can be replaced by the biggest remaining element that does not belong, does not have a category belonging to the last k. Now this guarantees that we are reducing the smallest profit, right? Adding the biggest remaining profit and increasing the number of unique count, right? One thing to note is that when we add the new element, new item, it must also be unique, right? Thus, if It must also be unique, right? Otherwise, we will not benefit from the increase of unique count, right? Yeah, that was pretty much it. Did you save it? Yeah, save it. Okay, well, that was a good problem, and then we went through this. Sort by profit. Sort by profit continuous. Yep. I think we're on to the same thing. So I'll keep my implementation. All right, we can move on to the next one. That was not too shabby, right? That was not too shabby at all. We are actually a little bit early, so we can do another one. But I'm gonna decide against it. You know, we just celebrate that we complete a difficult one today, using the idea from yesterday. And don't forget, we still have the typing to do today. So we're gonna do some typing. All right, that will be it for today. I will see you guys tomorrow. Adios.